Okay guys, so this is a series wound generator. That means the armature, the field coil and the load are connected in series, guys. So the power in is here at the armature, guys. The power in is here in the armature. That means there is a mechanical source here, meaning that there is a prime movers. So guys, so here at the armature, the prime movers rotate the armature, right? And the armature here is in full load. Know that, you can even write it down. There is a rotation here at the armature by means of prime movers, and this whole thing, it is at no load. That means there is no power. Remember, they create their own current. So at the moment, there is no power. It is still at no load when this whole thing is happening at the armature. So the armature will be the only thing that is in full load, remember. So the armature, it is rotated by prime movers at full load, and then the residual magnetic flux lines will be cut here at the armature. It will be cut, and when it is cut, it will create EMF, and that induced EMF will create smaller, sorry guys, that's the car outside. It will create smaller current, and that smaller current will be the armature current, and that armature current will move through a coil, guys. It will move through a coil, and when it moves through a coil, it changes into the coil armature, the field coil, the field armature. And that field armature, guys, will move until it will move through a load. Now it will move through a load, and it will change into a load current, guys. So by the moment it reaches the load current, guys, the main magnetic flux and the residual magnetic flux will be both cut. It will be both cut, and it will gradually grow. It will gradually grow until it reaches the maximum value, the maximum current and everything. You see, here the current starts smaller until it reaches the maximum value, and it moves through everything, the armature, the coil and the load. And the moment it reaches the load, it is power out. That means within the power out, there is electricity. Power in is mechanical power caused by mechanical rotation, and the power out is the electricity. And these are the important formulas. At the power out, there is electricity, guys. Remember, current is, there is electricity, guys. Power will be caused by voltage and the current, and power in is mechanical power. And here, because it's connected in series, the armature current, the coil current and the load current will be equal. Know that. And guys, this is the load characteristic of a series wound generator, guys. It is the same as the magnetizing curve in lesson 1 in the part 1. Remember that, guys. It also consists of point of saturation, guys. Point of saturation, there is no growth at all. Nothing can be absorbed or produced. It is a point where nothing can be absorbed or produced. There is no growth, guys. Remember, it grows gradually from small current to until it reaches the maximum values, meaning maximum EMF and maximum current, guys. And here it is a field current, guys, see, and a voltage. Know that it consists of terminal voltage and the field current, guys. And please, guys, please write this. Please write this, guys. The series wound generator, it is said to have a rising characteristics. Why? It has a rising characteristics because the full load voltage is greater than a no load voltage. Full load terminal voltage is greater than no load terminal voltage. Therefore, it has a rising characteristics. Know the load characteristics and know that, guys. And know that. So, guys, for the application of a serrant wound generator, it is used as the voltage booster on DC transmission lines. It is used as a voltage booster on DC transmission lines. Guys, know that is its application, voltage booster. Guys, and now we move to parallel wound or shunt wound generator, guys. For parallel wound, armature, coil, and load are connected in parallel, guys. Even here, guys, the power in is mechanically, guys. That means the same thing. A prime mover causes rotation in the armature while there is full load at the armature, and it is also has a no load. That means there is no power yet. The power is caused here in the armature where the residual magnetic flux are cut, and as they are cut, they produce the smaller EMF, and that smaller EMF create the smaller armature current until it moves from here. The current are not the same because it's in parallel. They move to the coil and they changes to shunt current now, and as it's still small, it's still smaller, it's smaller, it has smaller growth, guys. It's small. Yeah, I don't know how to put it in English, guys, but it grows smaller gradually. You see, that's what I was trying to say. It grows smaller gradually until it reaches the maximum values too, guys. And that as it moves here, it becomes the shunt current, and then after it will move through the load and it will turn into a load current, guys. See, and then it is the power out. Power out means that now there is electricity on this whole thing. There is electricity, guys, and now these are the important formulas. These are the important formulas. Know them. You see, the armature current, the current is not equal. The armature current is load current plus shunt current, and the power out means there is electricity. Power in is mechanical power. That means there is rotation by prime movers in the armature. And yeah, know this, the shunt current formulas. Yeah, and the shunt current is not, and the armature is not equal to voltage over resistant. The armature resistance, know that. They're very important. And guys, here is the load characteristic of a shunt wound or of a parallel generators, guys. So here it is said to have a dropping characteristics. Why? Because the full load is smaller. Full load voltage is smaller than no load terminal voltage. That's why it has a dropping characteristics, guys. Know that it is dropping because full load is smaller than no load, guys. And here they gradually grow together. The load current and the voltage, they gradually grow together until there is a voltage drop here. What will cause this voltage drop? It is caused by full load voltage being smaller than no load, and it is also caused by armature reaction, guys. It's also caused by armature reaction. Know that. And here we have the application. So for application of a wound or a parallel generator, it is suitable as a battery charges to suitable for battery charging, guys. Yes, and that is all about parallel and series wound generators. And now we will move on to compound. Okay guys, and now we move to compound wound generators, guys. Please note this or write this down, guys. A compounding wound consists of rising characteristics and dropping characteristics. Why? Because compound wound is the mixture of series wound and shunt wound or parallel wound. You see, a compound wound generator has two field coils, namely a series field and shunt field. You see, it is to combine the rising characteristics of a series wound generator and the dropping characteristics of a shunt wound generator. So what is the purpose of compound wound generator? Guys, the purpose of compound wound generator is to minimize the full load terminal voltage and the no load terminal voltage. Guys, know that. See, the purpose of compound wound machine is to therefore minimize the difference in terminal voltage between no load and full load, guys. It has to minimize it because remember, because of the dropping and the rising, remember series is rising, that means full load is greater than no load, and dropping shunt means that no load is greater than full load. So the purpose of compound was it is to minimize the difference in terminal voltage and no load, voltage between no load and full load. Know that. And now in compounded generators, we have long shunt generators, guys. In the long shunt generators, we have here the armature, which is connected in series and in parallel to the shunt field. This is the field coil and this is the shunt field. Series field coil, shunt field. So armature and series coil are connected in series and they are both connected in parallel to the shunt wound. You see, and they are connected in shunt wound and to the load, the voltage. So here it is series, you see, series coil and armature connected in series and in parallel to shunt and to voltage or the load. So we call it a long shunt. And we also have long shunt generators whereby the armature, you see now, they put in another connection for a shunt. Remember, on a long shunt, there was no this connection. That connection was here. It was long here. And now they made it short. They just connected it straight to armature and series field connection. See? So now it is like this. It's no longer connected in series because of this disturbance of the shunt wound. You see, now they made it short. They just removed this part. You see, remember here, it was like this. It went here, and now they removed this part and they just put it here. Long shunt, know how to draw both short shunt and long shunt generator, guys. And now we move to the characteristics of a compound wound. Remember, a compound wound is the mixture of both series and shunt wound, guys. So its load characteristics here, you see, voltage, and just want the whole thing to appear. Voltage and load current, guys. Okay, cool. over compounded, it's in series. It just basically means that the full load is greater than no load machine, so we call it over compounded. It's in series. It means that it is dominant field whereby full load terminal voltage is greater than no load, so we call it over compounded. And it's, remember, in series we had this growth, guys, on the load characteristics. And now we have under compound, which means, you know, the under compound, guys. Under compound means that the full load is smaller than no load. You see, full load terminal voltage is less than no load terminal voltage. That means the machine is said to be under compounded. And remember, guys, for under compounded we had that drop. Series we had the rise until it cannot rise, and here we had the voltage drop at the shunt wound, at the parallel. And guys, compound wound generators, they minimize both the terminal voltage of the full load and no load of both shunt and parallel, guys. So that means full load terminal voltage is nearly the same as no load voltage. That means we're going to have the level compounded. So it's said to be level compounded because full load terminal voltage is nearly the same as no load voltage. So this is how you draw it, guys. We have the rising over compound, dropping under compound, and here we want the desired voltage. You see the level compounded. This is how you draw it, guys. Know this. Okay, guys, and here we have cumulative compound wound generators. On cumulative compound wound generators, guys, know that the magnetic flux is a vector quantity. That means it can have both magnitude and direction. Okay, guys, so this is not important at all. It's not important. What to know about cumulative compound? Don't look at this. Don't look at these things, guys. What to know about them is that in cumulative compound wound generators, this is what is important. Know that the series field coil and the shunt field coil assist each other. They assist each other. The current ISE and I shunt current, the shunt current and the series current, they assist each other. Therefore, they put them in the same direction. That's why they say the magnitude, and that's why they said magnetic flux is a vector quantity. It has both direction and magnitude. So the magnitude are the same. You see, the magnitude of these things are the same. So they gave it, remember, they usually connected, the shunt and the series are usually connected in what? Parallel. They are usually parallel to each other at compound generators. But here they extended this extension connection to make it be in the same direction, so that the shunt current and the series current can assist each other. The series current is still connected in series to the armature, you see, and now it's no longer in parallel because of this thing does not reach here. You see, it's in the same direction. Know how to draw the cumulative compound wound generator. Remember, they assist each other, therefore at this connection, guys, ensure that they go in the same direction. And they are therefore used for the applications. Where are they applied? They are used for electrical railway or powering up of lamps to supply motors, guys. So cumulative compound are used as electric for railway and to power up lamps and to supply the motors. And then we have the differential compound with series. That means I shunt and ICE oppose each other. Now you see here they are differential compound series. You see the current and they oppose each other. This is the original compound long shunt compound wound, guys. Just the original. You see ICE and armature is in parallel. See, they just oppose each other. They don't assist each other now. They oppose each other, guys. You see, and the directions are very important. Know how to always show the directions, guys. Always show the directions. And where is it applied? It is used for welding purposes, guys. It is used for welding purposes. And this is the end lesson on generators, and next time we will be doing calculations. Thank you for tuning in. Please subscribe, please share, and please comment and tell me where to improve, guys. Please tell me where to improve, guys. Thank you. Have a nice day.